All right, so today we're going to be doing chapter 9.2, naming ionic compounds. Before the break, what we discussed was we did just how to name different ions, including polyatomic ions, transition metal ions. So we're going to start expanding our usage of this terminology and this vocabulary. And so we're going to start by naming ionic compounds. So yeah, let's get to it. All right, let me know if you have trouble seeing or reading anything at any point, and I can increase font size or whatever you need. All right, so we're going to be talking about naming binary ionic compounds. So binary, the word bi, okay, stands for two. So we're going to start by talking about ionic compounds that only have two elements in them total, all right? Hence the term binary, okay? Now, a binary ionic compound is formed by one type of metal element and one type of nonmetal. Okay, so there's only going to be two types of elements involved. That doesn't mean there's only two atoms of each element, but there's only going to be two types of elements involved. One's a nonmetal, one is a metal. Okay, reminder, how do you know what's a nonmetal and what's a metal? The nonmetals are to the left of that staircase thing on the periodic table, and the metals, the metals, excuse, I don't know what I said, but the metals are to the left, the nonmetals are to the right. And if you take a look, oh my gosh. Okay, so, you know, this staircase here, like where the green is, okay, to the right of that is your metal. Oh my gosh. It was a long break, or not long enough. To the right of the staircase is your non-metals, okay, and then everything to the left are your metals. All right, so if you have one of each, you're going to have what's called a binary ionic compound. Okay, so let's review really quickly. Okay, the name of your metal ions, or at least your standard metal ions, not your transition metal ions, are just the metal name plus the word ion. Okay, so example, Mg2 plus is the magnesium ion. All right, the names of the nonmetal ions, known as anions, you can add an IDE to the nonmetal name and then just add ion to the end. So an example here is F minus is the fluoride ion, right? So F is fluorine, so I drop the ene and change that to ide, and so I get F minus is the fluoride ion. Okay? Any questions there? Should be mostly review. All right, so to name a binary ionic compound, it's that you already have been given the formula for. It's really straightforward. Okay, you're just going to put the metal and the non-metal ion names together and just drop the word ion. All right, and you don't need to worry about the number of atoms of each element or anything like that. Okay, so you're just going to put metal, non-metal together and drop the words ion from it. Okay, so for example, NaCl, which you all know already, Na is the sodium ion, Cl is the chloride ion. All right, so when we put it together, we just get NaCl is sodium chloride. Okay, and so here are a couple of other examples. MgF2 is magnesium fluoride. Al2O3 is aluminum oxide. All right, again, notice that it does not matter how many, atoms of each element there are. So there's one magnesium here and two fluorines, but we still call it magnesium fluoride. All right, there's two aluminums and three oxygens, but we still call it aluminum oxide. You don't need to note for ionic compounds, you do not need to note how many atoms there are. Can anyone think of why you don't need to note the number of atoms? Or why the number of atoms is always going to be the same and therefore you don't need to note them? So the reason is because if you recall, every one of these metal and non-metal ions has a given charge. And so they're always going to form in the same ratio because I think I forgot to write this, but your ionic compounds, they're always going to have a net charge of 0. So Al has a charge of +3. So 2 Als is a charge of +6 total. O has a charge of -2, 3 O's is a charge of -6 total. All right, these ionic compounds, they always are going to have a charge of 0. All right, when we get to non-metal compounds, which are called covalent compounds later in the week, you will have to note how many of each atom there are, which is why naming gets confusing. Like I said, it's like learning a new language. It's like learning a different type of grammar. Okay, but right now with just the binary ionic compounds, it should be pretty straightforward. Any questions before I move us along? Okay, so let's practice. All right, so I have 4 different ionic compounds here. All right, I want you to write down what the names of those compounds are. Okay, can someone either tell me or write in the chat LIF? How would we name that ionic compound? What is LIF going to be? Go ahead.
It'll be lithium fluoride.
That's correct. Okay, so it'll be lithium fluoride. Oh, I don't need to type it. Mora and Katrina wrote it in the chat as well. Oh, if you guys do Dragon Ball combination thing, that's what you guys would be called. Okay, AlCl3. What is AlCl3? What is that ionic compound going to be named? Okay, it's going to be aluminum chloride, right? We just have aluminum. We have Cl, which is the chloride ion, so we just call it aluminum chloride. All right, Ca3P2, it's a little bit more complicated just because it's confusing, or not confusing, but tricky, like how you're going to name phosphorus. So what is Ca3P2? Somebody knew. All right, thank you, Leslie. Calcium phosphide. Okay, so phosphorus, you drop the orus and then you add ide, so it becomes calcium phosphide. I'm a little concerned that's only my Go group that's responding to me. I love you guys, but everyone else, you know, respond. Okay, make me feel like you're listening. All right, and then the last one, K2S. All right, K is potassium, S is sulfur, and so that is going to give us potassium sulfide. All right, so straightforward. Naming ionic compounds. We have not gotten to the transition metals yet. It gets a little bit more complicated, but we won't get to that until tomorrow. But naming these binary ionic compounds that already have set charges, you know, you just take the metal ion name, take the non-metal ion, make it an ide. Easy peasy. Okay. So, here are the answers. All right. Those are on the slides, which you have access to if you need. All right, going the other way around, it's only slightly more complicated, but really not. Okay, so if you're determining formulas of your binary ionic compounds, you know, the question is, if I give you the compound name, how do you get to the formula? All right, so it's a little bit more complicated, but we actually went over this in chapter 7, I think it was, the crisscross method. Okay, and this crisscross method, excuse me, works because the net charge of every ionic compound is always going to be 0, like I said. Okay, whoops, sorry. All right, so for example, sodium oxide. Okay, so if we're looking at sodium oxide, again, keep this handy, right? These columns, they always have the same charge. Okay, so sodium is in this column, so it has a +1 charge. Oxygen is in this column, so it has a -2 charge. Okay. At some point, you'll just have that memorized, at least for sodium and oxygen. They're used pretty frequently. All right. And so, sorry, I didn't know how to make the arrows fade in. All right. But sodium has a +1 charge. Oxygen has a -2 charge. So all I got to do is I got to use the crisscross method. So I say Na1+, O2-, and then I just crisscross the superscripts and make them subscripts and then get rid of the charges. Okay, so if I'm putting sodium and oxygen together, sodium oxide, I'm just going to get Na2O. Okay, see how I just crisscross that? All right, I put the 1 by the oxygen, but I didn't show it because it's given. I put the 2 in front of the sodium. Okay, so it's going to be Na2O. All right, magnesium nitride, same idea. So magnesium is a +2 charge. Again, I get that from the periodic table. Nitrogen is a -3 charge. I get that from the periodic table. Crisscross, applesauce, okay, Mg3N2. Okay, so when you get an ionic compound name, the formula, as long as you can find the charges, which you can find from the periodic table, you're just going to use the crisscross method to get the formula. All right, so let's do some practice with this. Okay, let's do these 4: potassium chloride, strontium fluoride, aluminum silicide, and magnesium oxide. All right, so let's go over these really quickly. So potassium chloride, what is potassium chloride going to be formula-wise? All right, potassium has a +1 charge, chlorine has a -1 charge, so very simple, KCl. Thank you, Mr. Chung's Go Group, once again. All right, strontium fluoride. Strontium is +2 charge. Fluorine is a 1- charge or a -1 charge. So what's strontium fluoride going to be? Okay, Sr +2, F -1, crisscross them. So it's going to be Sr1F2. Okay, strontium fluoride. This is hilarious. More people are typing, but they're all in my Go Group. It's like the whole Go Group is in solidarity. You guys are the best. All right, aluminum silicide. All right, silicon -2 charge, aluminum +3 charge. All right, we crisscross that. And so we're going to get Al2Si3. And then finally, magnesium oxide. I put this one on last, okay, because it's Mg2 plus and O2 minus. So when you crisscross, you're going to get Mg2O2. But notice, since they're both 2, I reduced it to MgO. Okay, so again, as long as you remember the crisscross method, as long as you remember you can use your periodic table to get the charges, coming up with these binary ionic compound formulas is pretty straightforward. Okay, again, when we add the transition elements tomorrow, it'll be a little bit more complicated, but still, this is the general premise, and everyone should be able to do this. Okay. Now, moving on to get a little bit more complicated. Oh, sorry. This should say, now we're going to talk about ionic compound formulas that are including polyatomic ions. Okay, so as a reminder, I just put this here on the slides for you so that if you need it, you have a place to refer to it. But these are the polyatomic ions you needed to memorize: NO3-, OH-, CN-, SO4 2-, CO3 2-, PO4 3-, NH4+, nitrate hydro. Why am I reading this? I'm moving on. Okay, you can read this. Okay, these are the formulas and their charges of these polyatomic ions. So if you're doing binary ionic compound formulas using the polyatomic ions, oh, screwed that up again. Okay, if you're doing ionic compounds with these polyatomic ions, you're just going to use the same crisscross method. However, you're just going to consider the polyatomic ion as a complete unit. And the easiest way to do that is to just put it into parentheses. All right, so let me show you how this looks. Sodium sulfate. Okay, so sodium, I'll type it in the chat, is a +1 charge or a 1+ charge. Sulfate is a 2- charge. All right, but I'm just going to consider sulfate as one thing. So, okay, sodium 1+ charge, so SO4 2- charge. I'm going to move the 2 in front of the sodium and then the 1 in front of the SO4, but there's only one of them, so I'll leave it as that. So the formula is Na2SO4. And remember, you can double check these because the charge has to be 0 total. So Na2 is +1 times 2, so there's a 2+ charge. SO4 is a -2 charge, so we have a net charge of 0, so we're good for Na2SO4. Okay? The next example, these should not even be here. The next example is ammonium oxide. Okay, so ammonium is NH4 +1. Oxygen is a 2- charge. So I'm going to do the crisscross method again, but notice what I'm talking about with the parentheses. Like I put ammonium in parentheses and I just put the 2 outside of the parentheses. All right. So NH4, okay, the way you actually say it out loud is you say it's NH4 taken twice and then oxygen. All right. Because each NH4 is +1 charge. When I have 2 of them, I have a +2 charge. Oxygen has a -2 charge and it balances out. Okay. So with polyatomics, just remember to keep putting them in parentheses. If I wanted to write, I'll put it in the chat, but if I wanted to write Na2SO4, I could have written it as Na2 parentheses SO4 close parentheses. Okay. You don't have to write it like that, but if you write it like that, you'll remember to keep the SO4 together. And not to split it up, because that's one unit. Another thing that I tell students to do sometimes is instead of saying SO4, you can change it to a variable like X or something like that, and then do all your crisscrossing with the charge and stuff like that. Get your formula and then replace the X with the SO4 or whatever variable. That helps some people, confuses some people. If it makes sense to you, it makes sense to you. Okay. Keep screwing this up. So when you're naming ionic compounds that have polyatomic ions, it's very simple. You just use the name of the polyatomic ion. You don't need to make any changes. You don't need to turn it into "ide" or anything like that. Okay. So a couple examples. MgOH2, all right, is magnesium hydroxide. Okay, hydroxide is one that confuses people a lot because you have oxide, right, which is an O ion, right? So remember, when you see hydroxide, it's always this OH, okay? But for example, MgOH2 or MgOH taken twice is magnesium hydroxide. CaCO3, calcium carbonate. Okay, notice I'm not changing the name of the ion at all. NH4 taken 3 times, PO4, is ammonium phosphate. Okay. CaNO3 taken twice, calcium nitrate. Okay, so here are just some examples of ionic compound names, including polyatomic ions. All right, so we're going to do some practice problems. Again, this is going to be part of your problem set that I'm going to assign tomorrow, but work on it now, ask me questions now, and so you will be ahead on that. Okay, I'm going to post a naming ionic compounds worksheet. All right, that one, I'll make copies for you. You can just put it there. Reminder, control period gives you a superscript. Control comma gives you a subscript if you need that. All right. And then in your book on page 298, 62, and 66, people have a lot of trouble with 66. So maybe you want to start with that in class today while we are talking. Okay. But that's it. I'm going to stop the recording. I'll post this to YouTube.